Hi everybody. So in the previous class we discussed about the organ like leaf and its functions and its modifications. Okay. So leaf is a dorsiventrally flattened structure of a plant which meant for photosynthesis. Okay. The main function of the leaf is that photosynthesis only. And in some cases that leaf is get modified into different structures which mean for special functions. Okay. Such as sometimes the leaf can modify in such a way that it can store the reserve food, as in case of onion, or sometimes the leaf is get modified to reduce the transpiration, or it helps in the protection, as in case of opuntia where leaves are modified to spines. And sometimes the leaflet is modified into tendril, which gives the support to the plant, as in case of pea. Okay. And in some specialized plants where they are unable to absorb the nitrogen properly. So in such plants, that plant depends on the insects for its nitrogen source. So in those plants, the leaf is modified into a different structure to trap the insects. So those plants are called as insectivorous plants, like Nepenthes. It is common as a pitcher plant, then the Dionaea, Venus flytrap, then the Drosera, okay, sundew plant. Okay, so these are all the plants where the leaf is modified into different structure to trap the insects. Okay, so these are all the things yesterday we discussed under the leaf. Okay, so today let us see one more topic. Is inflorescence. Okay, so far from the beginning we discussed about root, stem, then leaf. Okay, so the next is inflorescence. So what is this inflorescence? Okay, so in simple words, inflorescence is the arrangement of flowers on an axis. Okay, so here axis means like a stalk. On this stalk, so how the flowers are arranged? So whether the flowers are arranged like this, or whether on the axis flowers are arranged like this. Okay, whether the flowers are arranged like this. Okay, an axis, or on an axis of flowers are arranged like this. Okay, so like this, the flowers, if you look into in the nature, if you observe, the flower bunches, or it's called as inflorescence. So who gonjulu antivi kannadadalli. Okay, so all the flowers, they don't have the same pattern of the arrangement of flowers. So different plants shows different pattern of arrangement of flower. If you observe the sunflower, the arrangement is almost like this, and the stalk is almost like this, and that flowers are arranged like this. Okay, in onion, if you consider onion flower, the arrangement of flower is like this. Okay, in mustard, the arrangement of flower is like this. In jasmine, the arrangement is like this. Like this, different plants shows different pattern of arrangement of flowers. That pattern of arrangement of flowers on an axis is nothing but inflorescence. Okay, it is nothing but a bunch of flower. Bunch of flowers. And in very few cases it will not produce the bunches, instead of only one flower also produced per inflorescence. That is also there. Okay. So like this, when the flowers are arranged in a different pattern, they follow a specific order. Suppose if you consider these two cases, in these two cases, so the flowers which are present at the base, see there, let me write the unopened flowers here, like buds. Okay, so here bloomed flowers, or we call it as older flowers. So these older flowers are present at the base, whereas younger buds, they are present at the tip. So typically younger flowers irutte ಅಥವಾ buds irutte. So whereas in the base older flowers were there. And here in this case, so let me write this as a bud. So ಇದನ್ನ bud ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಇನ್ನು unopened flower. So this is the opened flower. So this is the old flower. So this is the bud or young flower. Okay, so like this the arrangement is different in these two cases. So based on this, whether the older flowers are present at the base or younger flower are present at the base, we have basically very two types of inflorescences. Okay, so those two types of inflorescence are racemose and cymose. Okay, so racemose and cymose are the two types of inflorescence based on the arrangement of flowers in a specific order. Okay, then let's see in detail what is that racemose and what is that cymose. So we'll draw the diagram again. Suppose this is a floral axis, if you call it as axis. This is the floral axis. Okay, on this floral axis, let's say flowers are produced like this. Okay, so here, so this is a floral axis. On the floral axis, flowers are arranged like this. So you can observe here. So here the whole flower is already bloomed, but here is in a bud condition, but it is in a very young condition. Okay, so here this is the tip. This is the tip of the floral axis, and this is the base. So tip and base are present here, and here, so this is the stalk of flower. So this is the stalk of flower. Okay, and this is flower, and it is bud of a flower. Okay, and these are also buds. Okay, so and let me call this flower which one is already bloomed. So this is older flower. This is older flower, but here these groups, so this one and this one, so let me call them as younger flowers. Okay, so older flowers and younger flowers. So what is the position of the older flower and younger flower? So here older flowers are present towards the base, whereas younger flowers, they are present towards the tip. Okay, so here older flower at the base, younger flower at the tip. This is one character. Okay, then the arrangement of this kind, younger at the tip, older at the base, it is called acropetal arrangement. Acropetal arrangement. So what is that acropetal arrangement? Younger at tip, older at base. Okay, it is called acro because the tip, another term for tip is acro. Okay, so in acropetal arrangement, younger flowers are present at the tip, older flowers are present at the base. Such type of arrangement is called as racemose inflorescence. So whatever the thing I explained right now, it is racemose inflorescence. Okay, so in racemose inflorescence, older flowers are present at the base and younger flowers are present at the tip in an acropetal arrangement, or it is also called as acropetal succession. Okay, so acropetal succession ಅಥವಾ acropetal arrangement ನಲ್ಲಿ ಈ ರೀತಿ flowers arrange ಆಗಿದ್ರೆ such type of inflorescence is called as racemose inflorescence. And one more important thing here, this axis can grow further. ನೋಡಿ ಇದು ಇನ್ನು ಮುಂದಕ್ಕೆ ಹೋಗ್ಬೋದು, ಮತ್ತೆ ಹೊಸ ಬಡ್ಸ್ಗಳು ಟಿಪ್ಪಲ್ಲಿ ಬರುತ್ತೆ, ಈ ಫ್ಲವರ್ಸ್ಗಳೆಲ್ಲ ಬ್ಲೂಮಿಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಆಕ್ಸಿಸ್ ಕ್ಯಾನ್ ಗ್ರೋ ಕಂಟಿನ್ಯೂಸ್ಲಿ. Axis can grow continuously. So if an axis can grow continuously means no doubt that inflorescence type is racemose. Okay, so hope you understand why it is called as racemose inflorescence and what is the arrangement of flowers in racemose inflorescence. Okay, so similarly one more type of inflorescence is there, that is cymose inflorescence. Okay, so this is racemose inflorescence where older flowers are present at the base and younger flowers present at the tip, and such type of arrangement of flowers is called as acropetal arrangement. And this acropetal arrangement is not only applicable to these flowers, even the same pattern is followed for the arrangement of leaves also. So in case of plants, older leaves are present at the base and younger leaves are present at the tip. Such type of arrangement is called as acropetal arrangement or acropetal succession. It is also called as acropetal succession. Okay, so ಇದನ್ನ acropetal succession ಅಂತ ಕೂಡ ಕರೀತೀವಿ. Okay, so acropetal succession means the arrangement of anything, older at the base and younger at the tip, whether it may be flowers or it may be leaves. Okay, yeah, so this is about one type called racemose inflorescence. Let's see the one more type of inflorescence called as cymose inflorescence. Okay. Next is cymose inflorescence. So it is cymose inflorescence is opposite to the racemose inflorescence in the way. So here is the inflorescence axis, you can observe it, the inflorescence axis is very short here. So I wrote the inflorescence axis for racemose like this. Okay, so this is the axis I wrote there. Okay, axis for racemose, and this is the axis for cymose. So here is the axis. So racemose has very long axis, cymose has short axis. Okay, so on this axis so here is the flower. Okay, so let me write, this is the stalk. So this is the stalk and this is the axis, and this is the stalk further, So let me label it as well. So this is stalk of flower. So this is stalk of flower. So here again the axis is there, where it has only buds. Okay, so this is flower bud. Okay, and observe here the arrangement of flowers you can observe here, whereas in this case in a racemose you observe older flower at the base, younger flower at the tip, but here older flower. So this is the older flower and this is the younger flower, and here is the tip, here is the base. So here towards the base are the younger flowers and towards the tip are the older flowers. Okay, and here in whether it may be racemose or a cymose inflorescence, you should consider the position of younger flowers. Should consider the position of young flower. So young flower basal ideo or tipal ideo. In case of racemose we told that younger flowers are present at the tip. So idakke acro anta helidvi, acro petal. But here older flowers, younger flowers are present towards the base. Okay, so such type of arrangement is called basipetal succession. So here in a cymose, younger flowers at the base, older flowers at the tip. Okay, such arrangement is called as basipetal arrangement. Basipetal arrangement or basipetal succession. So what is that basipetal? Younger at base, older at tip. So that is called basipetal arrangement, and you can observe here. So this is the axis. This axis ends with a flower. It cannot grow further. That main axis cannot grow further, but instead it shows the branches. It shows the branches at the base like this. Okay, so inflorescence axis ends with a flower. Inflorescence axis ends with a flower, and it shows branches at the base, and it shows branches at the base. Basally branch ಅನ್ನು produce ಮಾಡಿರುತ್ತೆ. Okay, so this is about cymose inflorescence. Okay, yeah, so hope you understand the difference between cymose inflorescence and racemose inflorescence. Okay, so let me give the differences there. So in case of racemose inflorescence, in racemose inflorescence, older flower at the base, younger flower at the tip. Whereas in cymose inflorescence, younger flower at the base, older flowers are at the tip. In racemose inflorescence, acropetal arrangement in cymose inflorescence, basipetal arrangement. In case of racemose inflorescence axis can grow continuously, whereas in cymose inflorescence axis ends with a flower. So this is the basic difference between racemose inflorescence and cymose inflorescence. Okay. So example, I forgot to tell that example for racemose inflorescence. So let me write the examples. Examples for racemose. Examples for cymose. So best example for racemose inflorescence is mustard inflorescence, mustard flower. Okay, so mustard inflorescence it is taken as a typical example for racemose inflorescence. Okay, so ಅಲ್ಲೇನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ older flowers ಹಿಂಗಿದ್ರೆ ಇದಕ್ಕಿಂತ old ಇರೋಂಥ flowers ಏನಾಗಿರುತ್ತೆ, they are modified into fruit. ಈ ಥರ ಫ್ರೂಟ್ ಆಗಿ ಮಾಡಿಫೈ ಆಗಿರುತ್ತೆ. Older flowers are developed into fruits. Younger flowers, ಅದಕ್ಕಿಂತ ಚಿಕ್ಕದಿರೋ flowers they are bloomed, ಇದಕ್ಕಿಂತ ಚಿಕ್ಕದಾಗಿರೋದು still they are in bud condition. Okay, so ಆ ಥರ ಇರುತ್ತೆ. Okay, so mustard and a cymose is jasmine. Okay, so jasmine ಅಲ್ಲಿ cymose inflorescence ಇರುತ್ತೆ. Okay, of course you can observe in the nature. You naturally observe ಮಾಡ್ತಾ ಇದ್ರೆ different types of pattern of flowers can be. You can only identify whether it is a cymose or racemose. Okay, just try to observe the inflorescence. Okay. So by that practical experience only you can learn the difference between the cymose and racemose very well. Initially it may be difficult, but you can familiar with the type of inflorescence. Just try to look into the different types of flowers. Okay, and for cymose I would like to add one more character. So here the main axis without any branches at the base ends with a single flower. ಇಲ್ಲಿ ತನಕ inflorescence axis ಇರುತ್ತೆ, then it has flower axis, the flower stalk. Okay, so ಈ ರೀತಿ one inflorescence which contains only one flower, when the inflorescence axis ends with one flower, it is called as solitary. So solitary is a type of cymose inflorescence. Okay, solitary inflorescence ends with single flower. Okay, solitary is single antane. Okay, so in the solitary inflorescence we can observe in hibiscus. Okay, on the inflorescence axis, so inflorescence axis typically one flower. Such type of inflorescence is called as solitary. That a solitary is a type of cymose inflorescence. Okay, so hope you understand what is inflorescence and types of inflorescence, how the types are differ from each other. You learned it. Okay, yeah. So next topic is flower. So far we discussed the root, stem, leaf and inflorescence. Okay, so next topic is flower. So flower is a very fascinating organ of a plant. Okay, so it is very attractive in nature. So the plants which produces these flowers, they are called angiosperms. So this only angiosperms produces the flower. So in the course of evolution, so starting from algae to angiosperm, so algae do not produce the flower, pteridophytes, bryophytes do not produce the flowers, gymnosperms do not produce the, bryophytes do not produce the flowers, pteridophytes do not produce the flowers, gymnosperms do not produce the flowers, but angiosperms produces the flower. So flower is a very fascinating structure of a flower which produces in the angiosperms, which is exclusively for the purpose of reproduction. Okay, that is sexual reproduction. Okay, so flower is produced for the purpose of sexual reproduction. So this is the structure which is meant for sexual reproduction. Okay, because these flowers contains male and female gametophytes. ಮೇಲ್ ಮತ್ತು ಫೀಮೇಲ್ ಗೆಮೆಟೋಫೈಟ್ಸ್ ಈ ಫ್ಲವರ್ನೊಳಗಡೆ ಇರುತ್ತೆ. ಸೊ ಬಿಕಾಸ್ ದ ಮೇನ್ ಪ್ಲಾಂಟ್ ಈಸ್ ಸ್ಪೋರೋಫೈಟ್ and that gametophytes are produced within these flowers. Okay, so just recall the type of gametophytes which are in lower plants. In the lower plant, the main, like in bryophytes, the main plant is itself a gametophyte, and that sporophyte is produced. But in case of angiosperm and gymnosperm, the main plant is a sporophyte, and that gametophyte is going to produce. So flower is meant to produce the male and female gametophyte. Okay, then technically what is the flower actually? So flower is a modified shoot. So flower is a modified shoot. Okay, so shoot system is a little modified into flower. Okay, so this flower we can compare with the cones of pteridophytes and gymnosperms. So where sporovils are aggregated together to form a compact structure called a cone. The same type of arrangement is observed in this flower, and we can compare these flowers to that cone, or rather we can compare that cone into these flowers. Okay, so let me explain why it is called as a modified shoot by comparing it with the cones. Okay, so this is a basic thing. Flower is a modified shoot which meant for sexual reproduction. Okay, and it is very attractive as well. So in case of pteridophytes, I explained the purpose of cone, how the cone is going to form. So here many sporophylls which produces sporangia. So idrelella itara sporangia iruvanta many sporophylls, they are aggregated. So sporophyll means a leaf like structure. So these are sporophylls. So these sporophylls aggregate together to form cone. Okay, or strobile as we call in case of pteridophytes and gymnosperms. Pteridophytes and gymnosperms, and these are sporophylls. So these are nothing but leaf like structures. Okay, so those leaves are modified and aggregated tightly to form a compact structure called as cone. In the same way in angiosperms. So here is the shoot system. That shoot system consisting of leaves, say this is the shoot system. Okay, so in this shoot system, so these are all leaves. So these are all leaves. These leaves, instead of develop into in a very young stage, very young stage allane andre innu arrangement ee tarane irutte innu. ಬ್ರಾಂಚ್ ಆಗಬೇಕಾದ್ರೆ ಈ ರೀತಿ ಬ್ರಾಂಚ್ ಆಗಬೇಕಾದ್ರೆ ಆಕ್ಸಿಲರಿ ಬಡ್ ಇಟ್ ಶುಡ್ ಡೆವಲಪ್ ಇಂಟು ಬ್ರಾಂಚಸ್ ಲೈಕ್ ದಿಸ್. ಸಪೋಸ್ ದಿಸ್ ಇಸ್ ದ ಈ ಒಂದು ಲೀವ್ ಇರುತ್ತೆ, ಇದು ಬ್ರಾಂಚ್ ಈ ಥರ ಗ್ರೋ ಆಗಬೇಕಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಆಕ್ಸಿಲ್, ಸ್ಟೆಮ್ನ ಆಕ್ಸಿಲ್. ಅದು ಆಕ್ಸಿಲಿಂದ ಈ ರೀತಿ ಬ್ರಾಂಚ್ ಆಗಿ ಡೆವಲಪ್ ಆಗಬೇಕಿರುತ್ತೆ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಡೆವಲಪ್ ಇನ್ ಟು ಎ ಬ್ರಾಂಚ್, ದಿಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಲಿಟಲ್ ಮಾಡಿಫೈ ಇನ್ ಟು ಡಿಫರೆಂಟ್ ಅಪೆಂಡೇಜಸ್ ಆಫ್ ಎ ಪ್ಲಾಂಟ್ ಫ್ಲವರ್. ಓಕೆ, ಸೊ ನೋಡ್ಕೊಳ್ಳಿ, ಈಗ ಇದು ಆಕ್ಸಿಲಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರುವಂಥ ಸ್ಟ್ರಕ್ಚರ್ ಏನಿದೆ. ನಾವು ದೀಸ್ ಲೋಯರ್ ಲೀವ್ಸ್, ಇದನ್ನು ತುಂಬ ಚಿಕ್ಕ ಸ್ಟ್ರಕ್ಚರಲ್ಲಿ ಆಗ್ತಾ ಇರೋ ಪ್ರೋಸೆಸ್ ಇದು. ದೀಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ದೇ ಆರ್ ಮಾಡಿಫೈ ಇನ್ ಟು ಲೈಕ್ ದಿಸ್. ಇದು ಈ ರೀತಿ ಮಾಡಿಫೈ ಆಗುತ್ತೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಓಕೆ, ಆ್ಯಂಡ್ ದೀಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ಸೊ ದೀಸ್ ಸ್ಟ್ರಕ್ಚರ್ ದೇ ಆರ್ ಮಾಡಿಫೈಡ್ ಲೈಕ್ ದಿಸ್. Okay, and these structures, these are modified into like this. These are modified into like this. These are also modified like this. And the top one get modified. So ಇದೆಲ್ಲ ಈ ರೀತಿ ಲೀವ್ಗಳು ಹಿಂಗಿರುತ್ತೆ, ಹೀಗಾಗುತ್ತೆ. Then it produces a stalk-like structure like this. ಈ ರೀತಿ ಮಾಡಿಫೈ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಮಾಡಿಫಿಕೇಶನ್ ನೆವರ್ ಅಕರ್ಸ್ ವೆನ್ ದ ಬ್ರಾಂಚ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಕಂಪ್ಲೀಟ್ಲಿ ಫಾರ್ಮ್ಡ್. ಸೊ ಬಿಫೋರ್ ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ದಟ್ ಬ್ರಾಂಚ್ ಇಟ್ ಸೆಲ್ಫ್, ಇನ್ ದ ವೆರಿ ಯಂಗರ್ ಸ್ಟೇಜ್, ದಿಸ್ process takes place. Okay, now so let me explain this. So base leaves, the leaves which are present at the base, so ಈ ಬೇಸಲ್ಲಿ ಇರುವಂಥದ್ದು they are modified like this. ಈ ಥರ ಮಾಡಿಫೈ ಆಗುತ್ತೆ. ಓಕೆ, ಆ್ಯಂಡ್ ಅದರ ಮೇಲ್ಗಡೆ ಇರುವಂಥದ್ದು ಆ್ಯಂಡ್ ಸಮ್ ಲೀವ್ಸ್ ಈ ಥರ ಲೀಫ್ ಆಗಿ ಡೆವಲಪ್ ಆಗಬೇಕಿರುತ್ತೆ. ಇನ್ಸ್ಟೆಡ್ ದೇ ಆರ್ ಮಾಡಿಫೈಡ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಆ್ಯಂಡ್ ಸಮ್ ಲೀವ್ಸ್ ದೇ ಆರ್ ಮಾಡಿಫೈಡ್ into the structure like this, okay, and some leaves, let's say 2 leaves, these are 2 leaves together, they modify into the structure like this. Okay, so ee riti many leaves are modified into different appendages of a flower. Okay, and this whole structure ಈಗ ನೋಡಿ ಇಷ್ಟುದ ಏನು ಸ್ಟ್ರಕ್ಚರ್ ಇದೆ. ಸೊ ವೆರೆವರ್ that leaves is going to produce, that part is called as a node. Between that node is the internode. Just imagine this internode is get condensed. ಇಂಟರ್ನೋಡ್ ಇಲ್ಲ ಅಂದರೆ ಇವೆಲ್ಲ ಒಂದೇ ಕಡೆ ಗ್ರೂಪ್ ಆಗಿಬಿಡುತ್ತೆ. ಸೊ ಆ ರೀತಿ ಆದರೆ ಯಾವ ಥರ ಸ್ಟ್ರಕ್ಚರ್ ಆಗುತ್ತೆ. If internode is absent, these two and this, okay, then these, okay, then this one. This is from one leaf and this is from other leaf. Like that they are going to arrange. Okay, so this is the reason why flower is said to be modified shoot. It is modified shoot. Shoot system is modified into different appendages of a flower. So this appendage is called as calyx, this appendage is corolla, this appendage is stamen, this appendage is pistil. Okay, so different leaves are modified into different structures of a flower. Okay, so nodi idiga stalk agutte. So this is the stalk, so this is calyx, this is corolla, these are stamen, this is pistil. So like that, different floral appendages are modified into different appendages of a flower, like a calyx, corolla, stamen and pistil. So this is how shoot is modified into flower. Okay, the same structure ನೋಡಿ ಅದೇ ತರದ ಇಲ್ಲೂ ಕೂಡ ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲೂ ಕೂಡ ಡಿಫ್ರೆಂಟ್ ಫ್ಲವರಲ್ ಅಪೆಂಡೇಜಸ್ ತರಾನೇ ಇರೋ ಸ್ಟ್ರಕ್ಚರ್ಸ್ಗಳೆಲ್ಲ ಒಂದಕ್ಕೊಂದು ಸೇರ್ಕೊಂಡಿರುತ್ತೆ, ಬಟ್ ದೇ ಆರ್ ಆಲ್ ಸೇಮ್. ಇಲ್ಲಿರೋದೆಲ್ಲ ಒಂದೇ ಥರ ಇರುತ್ತೆ, ಲೈಕ್ ಈ ಥರನೇ. ಅಲ್ಲಿರೋದೆಲ್ಲ ಒಂದೇ ಶೇಪಲ್ಲಿ ಇರುತ್ತೆ, ಬಟ್ ಹಿಯರ್ ದೇ ಆರ್ ಮಾಡಿಫೈ ಇಂಟು ಡಿಫ್ರೆಂಟ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಲೈಕ್ ದಿಸ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಫ್ಲವರ್. ಓಕೆ, yeah, so this is the reason why flower is said to be modified shoot. Okay. Then, so here the arrangement of these appendages. Okay, ನೋಡಿ ಇಲ್ಲೊಂದು ಸ್ವಲ್ಪ ಸೋಲನ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಗಿರುತ್ತೆ. So on this solon structure, all these appendages are going to produce. So that appendage, that structure is called as thalamus. Okay, on this thalamus all the floral appendages are arranged. Okay. Okay, so the stalk of flower is slightly swollen at the tip. On this thalamus floral appendages like calyx, corolla, androecium, the pistil and the stamens are going to produce. Okay, so this is about the flower. And sometimes flowers may be bisexual or unisexual. Okay, andre two sexual organs like a pistil and a stamens. If both pistil and stamens are present on the same flower, ನೋಡಿ pistil ಮತ್ತು stamen ಎರಡು ಒಟ್ಟಿಗೆ ಇತ್ತು ಅಂದ್ರೆ it is bisexual flower. Similarly, unisexual flowers are also there, where a single flower consisting of only stamen and sometimes the flowers consisting of only pistil. Such type of flowers are unisexual. So we write bisexual. Flowers contains both pistil and stamen, is bisexual. Okay, so whereas unisexual, flower either contains pistil or stamen. ಅಥವಾ ಫ್ಲವರಲ್ಲಿ ಒಂದು ಪಿಸ್ಟಿಲ್ ಇರುತ್ತೆ, ಇಲ್ಲ ಸ್ಟೇಮನ್ ಇರುತ್ತೆ. ಓಕೆ, ಓನ್ಲಿ stamen containing flower is staminate. ಓನ್ಲಿ ಸ್ಟೇಮನ್ಸ್ ಮಾತ್ರ ಇರೋ ಫ್ಲವರ್ಸ್ನ ಸ್ಟಾಮಿನೇಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂಡ್ ಓನ್ಲಿ ಪಿಸ್ಟಿಲ್ containing flower is pistillate. ಅಂತದನ್ನ ಪಿಸ್ಟಿಲೇಟ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಸ್ಟಾಮಿನೇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಮೇಲ್ ಫ್ಲವರ್ and pistillate is nothing but female flower. Okay, so this staminate and pistillate flowers, they are produced in papaya. Okay, papaya flowers ನಲ್ಲಿ ಸ್ಟಾಮಿನೇಟ್ ಫ್ಲವರ್ಸ್ ಇರುತ್ತೆ ಮತ್ತು ಪಿಸ್ಟಿಲೇಟ್ ಫ್ಲವರ್ಸು ಇರುತ್ತೆ. ಪಪಾಯದಲ್ಲಿರುತ್ತೆ, ದೆನ್ ಕೋಕೋನಟ್ಟಲ್ಲಿರುತ್ತೆ, ಕುಕುಂಬರ್ನಲ್ಲಿರುತ್ತೆ. Okay, and example for bisexual, most of them are bisexual flowers. Common flowers ಏನು ನೋಡ್ತಿರ್ತೀವಿ ಅವೆಲ್ಲ bisexual flowers ಇರುತ್ತೆ. So start observe the flowers, just pluck the flower and observe whether it contains pistil or stamens. If you start observing it, you came to know the difference between the bisexual flowers and the unisexual flowers. Okay. Yeah, so this is about the flowers based on whether they have contains stamens and pistil, both are single. Okay. And let's come to the symmetry of flower. So whatever the diagram I wrote here, it is an example for a bisexual flower. So next come to the symmetry. The symmetry. So symmetry means if you take a flower and imaginarily if you cut into two equal halves, okay, ತರ ಕಟ್ ಮಾಡಿದ್ರೆ ಮಿರರ್ ಇಮೇಜ್ ತರ ಈಕ್ವಲ್ ಹಾಲ್ಸ್ ಬರ್ತಾ ಇರೋದು ಒಂದಿಷ್ಟು ಫ್ಲವರ್ಸ್ ಇರುತ್ತೆ. ಅಂಡ್ ಇನ್ ಸಚ್ ಸಮ್ ಫ್ಲವರ್ಸ್ ಯು ಕ್ಯಾನ್ ಕಟ್ ಇನ್ ಟು ಎನಿ ಡೈರೆಕ್ಷನ್ ಆರ್ ಎನಿ ಆಕ್ಸಸ್, ಎನಿ ಪ್ಲೇನ್ ಆಫ್ ಆಕ್ಸಸ್ into two equal halves. That is one kind of symmetry. And in some plants you can get, in some flowers you can get the two equal halves only in one direction. If you cut in this direction only, it can get the two equal halves. If you cut in this direction, they are unable to produce the two equal halves. Okay, so that symmetry is different. Okay, and in some flowers in any plane you cannot get the mirror images, or you cannot get the equal halves. Okay, so such type of flowers are irregular flowers. So symmetry, either flowers may be in case of animals it is called as radial symmetry. Okay, so animals ಅಲ್ಲಿ ಈ ತರ animals ನ equal halves ಕಟ್ ಮಾಡೋದನ್ನ, ಯಾವ ಡೈರೆಕ್ಷನ್ ಕಟ್ ಮಾಡೋದು equal halves ಆಗೋದನ್ನ ರೇಡಿಯಲ್ ಸಿಮೆಟ್ರಿ ಅಂತ ಕರಿತೀವಿ ಅದರಲ್ಲಿ. Okay, so but in flowers they are called as actinomorphic flowers. Actinomorphic flowers. And second one is zygomorphic flowers. Okay. Third one is there, irregular flower. Okay. So what is that actinomorphic flower? If imaginary line cut the flower into two equal halves in any plane. In any plane it is called as actinomorphic flower. Then a zygomorphic. If imaginary line cut the flower into two equal halves in only one direction. Okay, in only one plane, not direction, only one plane. Okay, it is called zygomorphic flower. Then irregular flower cannot get two equal halves in any plane. ಯಾವ ಪ್ಲೇನಲ್ಲಿ ತಗೊಂಡ್ರು ಈಕ್ವಲ್ ಹಾಲ್ಸ್ ಬರಲ್ಲ ಅಂತವನ್ನ ಇರ್ರೆಗ್ಯುಲರ್ ಫ್ಲವರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಆಕ್ಟಿನೋಮಾರ್ಫಿಕ್ ಫ್ಲವರ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಐಬಿಸ್ಕಸ್. ಸೊ ಐಬಿಸ್ಕಸ್ ಫ್ಲವರ್ಸ್ನ ತಗೊಂಡು ನೀವು ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ಕಟ್ ಮಾಡಿದ್ರು ಕೂಡ, ಯಾವ ಪ್ಲೇನಲ್ಲಿ ಕಟ್ ಮಾಡಿದ್ರು ಕೂಡ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ದ ಟೂ ಈಕ್ವಲ್ ಹಾಲ್ಸ್. ವೆರ್ ಆಸ್ ಇನ್ ಝೈಗೋಮಾರ್ಫಿಕ್ ಫ್ಲವರ್ ಸಚ್ ಆಸ್ pea flower. ಪೀ ಫ್ಲವರ್ ಓಕೆ ಅಂದರೆ ಆಲ್ ಪಲ್ಸ್ ಪ್ರೊಡ್ಯೂಸಿಂಗ್ ಪ್ಲಾಂಟ್ಸ್ ಪಲ್ಸಸ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋ ಪ್ಲಾಂಟ್ಸ್ ಇರುತ್ತಲ್ಲ ಆ ಪ್ಲಾಂಟ್ಸಲ್ಲಿರೋ ಫ್ಲವರ್ಸ್ನ ಓನ್ಲಿ ಇನ್ ಒನ್ ಪ್ಲೇನ್ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ದ ಟೂ ಈಕ್ವಲ್ ಹಾಲ್ಸ್. ಇಫ್ ಯು ಕಟ್ ಇನ್ ಅನದರ್ ಡೈರೆಕ್ಷನ್ ಯು ಆರ್ ಅನೇಬಲ್ ಟು ಗೆಟ್ ದ ಟೂ ಈಕ್ವಲ್ ಹಾಲ್ಸ್. ಓಕೆ ಸೊ ಅಂತ ಟೈಪ್ ಇದು ಎಕ್ಸಾಂಪಲ್ ಪೀ ಪ್ಲಾಂಟ್ಸ್. ಸೊ ಪೀ ಪ್ಲಾಂಟ್ ಇಸ್ ಝೈಗೋಮಾರ್ಫಿಕ್ ಆ್ಯಂಡ್ ಇರ್ರೆಗ್ಯುಲರ್ ಫ್ಲವರ್. ಸೊ ವೇರ್ ಇನ್ ನೋ ಡೈರೆಕ್ಷನ್ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ದ ಟೂ ಈಕ್ವಲ್ ಹಾಲ್ಸ್. ಇದಕ್ಕೊಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ there is a plant called canna. Okay, canna is an example for irregular flower. Okay. So this is about the symmetry of flower, how the appendages are arranged, whether if you cut the imaginary line whether all the appendages are equally distributed or not. So based on that, so you have actinomorphic flowers, zygomorphic flowers and irregular flowers. Okay. So ಈ actinomorphic flower ಗೆ so there is in the future class you came to know there is a thing called floral formula. So in that floral formula we can define this actinomorphic flower by a symbol. ಇದಕ್ಕೊಂದು symbol ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ ಸೊ actinomorphic flower ಗೆ symbol ಪ್ಲಸ್ ಮಾರ್ಕ್ ಹಾಕಿ ಒಳಗಡೆ ಈ ಥರ ಸರ್ಕಲ್, a circle which contains plus mark which indicates actinomorphic flower. And for zygomorphic flower symbol is percent. ಓಕೆ ಸೊ ಪರ್ಸೆಂಟ್ ಸಿಂಬಲ್ನ ಹಾಕಿದ್ರೆ ಇದು ಝೈಗೋಮಾರ್ಫಿಕ್ ಫ್ಲವರ್ ಆಗುತ್ತೆ. ಓಕೆ ಸೊ ನೋ ಸಿಮೆಟ್ರಿ ಅಂತಂದರೆ ಜಸ್ಟ್ ಏನು ಸಿಂಬಲ್ ಬರೀದೇ ಇದ್ದರೆ ಇಟ್ ಈಸ್ ಇರ್ರೆಗ್ಯುಲರ್ ಸಿಮೆಟ್ರಿ ಅಂತ ಆಗುತ್ತೆ. ಸೊ ರಿಮೆಂಬರ್ ಆಕ್ಟಿನೋಮಾರ್ಫಿಕ್ಗೆ ಈ ಥರ ಬರೀತೀವಿ, ಝೈಗೋಮಾರ್ಫಿಕ್ಗೆ ಪರ್ಸೆಂಟ್ ಸಿಂಬಲ್ ಹಾಕ್ತೀವಿ. ಓಕೆ ಸೊ ಐ ವಿಲ್ teach it again, I will tell it again. Okay, so in that floral formula class again, just remember it, actinomorphic flower plus symbol and a zygomorphic percent symbol. Okay, so this is about the symmetry of flower. Then so based on number of floral appendages, how many calyx, how many corolla, how many stamens, how many pistils are present. So based on that, flowers may be based on number of floral appendages. Flowers may be trimerous. Okay, tri means 3. That means calyx, corolla, stamen, pistil, present in the multiples of 3. 3 ಇರಬೇಕು ಅಥವಾ ಮಲ್ಟಿಪಲ್ಸ್ ಆಫ್ 3 ಇರುತ್ತೆ. ಟೆಟ್ರಾಮಿರಸ್ present in the number 4 or multiple of 4. ಅಂದರೆ 4 ಇರ್ಬೋದು, 8 ಇರ್ಬೋದು. ಅಂದರೆ ಈ ಕೇಸಲ್ಲಿ ಟ್ರೈಮಿರಸಲ್ಲಿ ಕೇಲಿಕ್ಸ್ 3 ಇರ್ಬೋದು, ಕರೋಲಾ 3 ಇರ್ಬೋದು, ಸ್ಟೇಮನ್ 3 ಇರ್ಬೋದು, ಪಿಸ್ಟಿಲ್ 3 ಇರ್ಬೋದು, ಅಥವಾ ಕೇಲಿಕ್ಸ್ 6, ಕರೋಲಾ 6, ಸ್ಟೇಮನ್ 6, ಪಿಸ್ಟಿಲ್ 6, 3 ಆರ್ ಮಲ್ಟಿಪಲ್ಸ್ ಆಫ್ 3. ದ ಸೇಮ್ ಇವೆ ಟೆಟ್ರಾಮೆರಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ನಂಬರ್ ಆಫ್ 4. ಕೇಲಿಕ್ಸ್ 4 ಇರುತ್ತೆ, ಕರೋಲಾ 4 ಇರುತ್ತೆ. ಅಂದರೆ ಇಂಡಿವಿಜುವಲಿ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅ ಸೆಪಲ್ ಅಂಡ್ ಪೆಟಲ್. ಸೆಪಲ್ಸ್ 4, ಪೆಟಲ್ 4, ಸ್ಟೇಮನ್ 4, ಪಿಸ್ಟಿಲ್ 4, ಲೈಕ್ ದಟ್. ದೆನ್ ಪೆಂಟಾಮೆರಸ್ present in the number of 5 or multiple of 5. Sepals 5, petals 5, stamen 5, pistil 5. Then multiples of 5 ಅಂತ ಹೇಳ್ತೀವಿ. So usually trimerous flowers. So trimerous flowers can observe in monocots. ಎಷ್ಟೊಂದು monocots ಅಲ್ಲಿ ಇರುತ್ತೆ. So give an example for that trimerous lily flowers. Okay, ಸೊ ಲಿಲಿ ಫ್ಲವರ್ಸಲ್ಲಿ ಟ್ರೈಮಿರಸ್ ಇರುತ್ತೆ. ಟೆಟ್ರಾಮಿರಸ್ಸಿಗೆ ಕ್ಯಾನ್ ಗಿವ್ ದ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಮಸ್ಟರ್ಡ್. ಪೆಂಟಾಮಿರಸ್ಗೆ ಕ್ಯಾನ್ ಗಿವ್ ದ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಹೈಬಿಸ್ಕಸ್. ಸೊ ಮೋಸ್ಟ್ ತುಂಬ ಜಾಸ್ತಿ ಇರೋದು ಯಾವುದು ಅಂದರೆ ಈ ಪೆಂಟಾಮಿರಸ್ ಟೈಪ್ ಆಫ್ ಫ್ಲವರ್ಸು ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಓಕೆ, so this is about the number of floral appendage. We can classify the flowers into trimerous flowers, tetramerous flowers, or pentamerous flowers. Okay. So let us solve one question for need. With the class of fungi that produces both exogenous and endogenous spores is either basidiomycete, phycomycete, deuteromycete, or ascomycete. The question is regarding the fungi which produces both exogenous and endogenous spores. So exogenous spores are the spores which are produced externally, whereas endogenous spores, they are produced internally within a sac-like structure. So among these four classes of fungi, which fungi produces that exogenous and endogenous both? Okay, so ಎರಡು ತರ spores ಅನ್ನು produce ಮಾಡುವಂತದ್ದು ಯಾವುದು fungi ಅಂತ ಹೇಳಿ. Okay, suppose if you consider the basidiomycete. In basidiomycete, the spores are produced on basidia. Spores are produced on basidia, and these basidiospores are exogenous spores. So these are exogenous. They produces only exogenous spores. So these are basidiospores. So basidiomycete reproduce sexually, only sexually, and the basidiospores which are produced exogenously, and it do not produces endogenous spores. So it is not the right answer then. Okay, next come to phycomycetes. So in phycomycetes, the spores which are produced within a sporangia. So within a sporangia, spores are produced like this. Okay, so this is the sporangia, and these are spores. So here spores are produced within a sporangia. So these spores are endospores. So these spores are endospores. Okay, and in phycomycetes, that aplanospores are zoospores which are produced within sporangia itself. So this is not the right answer. Okay, then come to deuteromycete. In case of deuteromycete, the spores are produced, usually they are produced externally. So ಈ ರೀತಿ external spores ಅಂದರೆ exogenous spores ಗಳೇ produce ಆಗ್ತಾ ಇರುತ್ತೆ. Okay, so these are called as conidia. You know, conidia are exogenous spores. They are exogenous spores, and they do not produce endogenous spores, since it is reproduced only by asexual method. All the asexual spores are exogenous in nature. So this is not the right answer. If you come to the ascomycetes, in ascomycetes, like in penicillium, these exogenous are also produced, exogenous spores are also produced for asexual method. And in a sexual method, spores are produced within a ascus. So within a ascus, spores are produced. So these are exogenous in nature, and these are endogenous. So by considering this, we can say ascomycete fungi reproduce both by exogenous spores and endogenous spores. So this is the right answer. Okay, so this is how we can solve the question easily. So you should know what is exogenous and endogenous, and remember this these spores like ascospores and these basidiospores. So these are the sexual spores of ascomycete and basidiomycete respectively, and these sexual spores, among these sexual spores, basidiospores are purely exogenous, and ascospores, so these are ascospores, and these ascospores are purely endogenous. But ascomycete fungi in asexual method, they produces exogenous spores. Okay, athwa in another way we can ask the questions a little bit, we can change it. So class of fungi that produces exogenous asexual and endogenous sexual spores. The question may be asked like that also. Okay, so we can a little modify that, or even the same question by changing the options. You can change the options by giving examples. So class fungi that produces both exogenous asexual and endogenous sexual spores is let me write Alternaria, now instead of a class we can give the examples as well. So Puccinia, Penicillium, then Rhizopus. Okay, instead of class we can give the example as well. The fungi that produces both exogenous asexual and endogenous sexual spores. So Alternaria, it belongs to Basidiomycete. So in so it belongs to Deuteromycete. So here Deuteromycete fungi which do not produces sexual spores, so no sexual spores. So this is not the right answer. Then Puccinia, it belongs to Basidiomycete. So in Basidiomycete, no asexual spores. So no, it is not the right answer there. Then come to Penicillium. So Penicillium, it belongs to Ascomycete. So Ascomycete, for asexual it produces Conidia, and in sexual it produces Ascospores. Okay, then come to Rhizopus. It produces asexual spores, but endogenous and sexual spores, that is also endogenous. Eradu kuda endogenous irutte. Whereas in Ascomycete, Conidia are exogenous and Ascospores are endogenous. Okay, so right answer is Penicillium. Okay, so exogenous asexual spores, asexual, exogenous, and the sexual endogenous. Okay, so you should know the concept like which class of fungi which produces exogenous and endogenous, and you should remember the examples as well. Then you can analyze it properly and you can choose the best answer. Okay, so here you are going to eliminate the first one, second one, then ended up with the 2-1. Then you can directly choose the right answer and by eliminating this. Okay, so like this you can choose the right answer. Okay, so let us solve one need level question. What is the ratio of 15N and 15N is to 15N and 14N is to 14N and 14N DNA at the end of 8th generation in Michelson and Stahl experiment. So option A, 1:1:32, 1:1:254, 0:2:126, 0:1:127. So these are the options. So in Michelson and Stahl, so you grow the bacteria E. coli in the media which contains 15N isotope of nitrogen for several generations, and they shifted to the bacteria into 14N and continue for 2 generations there. Okay, so when he started the experiment with 15N and 15N, so this is 15N DNA and 15N DNA. It grows for several generations. Then he shifted those bacteria which contains this 15N to 15N into the media which contains 14N nitrogen. Okay, so in the first generation, so what he got? So these two strands of DNA are separated. New strand is going to synthesize. That a new strand which contains 14N, and this is the parent strand, 15N. So this is the result he got in the first generation. That means here both the DNA which contains 14N, 15N, it is called as a hybrid DNA. So this is hybrid DNA, the number is 2 here, and this is the heavy DNA. So this is heavy DNA where both the strands contains 15N, 15N. So here, so this is heavy DNA, and this one is hybrid DNA, and this one is called as light DNA. It is called light DNA. So in the second generation, if you continue for the second generation, what happens? These DNA again get unwinded. Again, new strand is going to be synthesized. So new strand is again which contains 14N, like this. Okay, so at the end of a second generation, so how many are 14N and 15N? Let's see, 15N, only 2 DNA which contains the strand which has a 15N, and remaining all are having 14N. See here, there is no heavy DNA in successive generation. So first generation allo kuda there is no hybrid DNA. Second generation, sorry, there is no heavy DNA. In the second generation also there is no heavy DNA. So in the question they can be asked like this also, what is the ratio of heavy and hybrid and light DNA at the end of 8th generation? Ee taranu kuda question kelbodu. Okay, so so this is the light DNA. So this is the light DNA, and this is hybrid. This is hybrid. So what is the ratio here? Heavy DNA is absent, whereas hybrid DNA is 2 and the light DNA is 2. That is equal to 1:1 ratio at the end of second generation. So it can be continued to 3rd, 4th, 5th and 6th generation onwards. So in every successive generation, this heavy DNA will be 0. Heavy DNA will be 0. 0 antandre 2 chances were there. So you can eliminate this, because heavy 15N and 15N DNA is always 0 in the successive generations. Okay, and in how many generation you can continue, the amount of this hybrid DNA remains the same. You should remember this. It should be remain same, that is 2. This 15N and 14N remains 2 always. ಯಾವಾಗಲೂ ನಂಬರ್ 2 ಇದ್ದೇ ಇರುತ್ತೆ, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಗಲ್ಲ, ಕಡಿಮೆನೂ ಆಗಲ್ಲ. ಬಟ್ ದ ಅಮೌಂಟ್ ಆಫ್ ದಿಸ್ ಲೈಟ್ DNA 14N and 14N is keep on increasing. ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಯು ಕೆನಾಟ್ ರೈಟ್ ಲೈಕ್ ದಿಸ್ ಫಾರ್ ಅಪ್ ಟು 8th generation. Okay, so it is very cumbersome. It is not possible to write this pattern up to 8th generation and calculate how many hybrid and how many light DNA are there. So for this we can use a small trick. Okay, so let's see that trick. What is the trick? Remember 14N light DNA, the number is keep on increasing with the successive generations. So before that you should remember one small thing here. Heavy DNA andre 15N remains 0. ಯಾವಾಗಲೂ 0 ಆಗಿರುತ್ತೆ. Hybrid DNA, that is 15N and 14N remains always 2, remains always 2. A number change ಆಗೋದಿಲ್ಲ, it remains 2 always. And the amount of light DNA, that is 14N and that 14N it can be calculated because it is keep on increasing. It can be calculated by using a simple relation 2 raised to n minus 2, where n is the number of generations. Okay, so for the given question, so what will be the number? Let's see. So these two are constant then, so 2 raised to n minus 2. So they had given 8th generation, so 2 raised to 8 minus 2. So if you calculate 2 raised to 8 is equal to 256. 256 minus 2, that is equal to 254. Okay, so 254 will be the amount of this light DNA at the end of 8th generation. Okay, so then what will be the ratio? So 14 and 15 and 15n, that is 15n is to 15n 14n is to 14n and 14n. So amount is always 0, I told, and 15n 14n remains 2 always, and 254 14n and 14n will be 254, and search for the option now. Okay, so 0 0 2 1, but here is a second 15 and 14n is 2, but here is 1 126. So you can simplify it further. 0 is to 1 is to 127. Okay, so this is not the right answer, then this is the right answer. So this is wrong one. So by using this simple relation, you can calculate the amount of light DNA. That you should remember. Amount of light DNA can be calculated by using this 2 raised to n minus 2. You can calculate for second generation as well. 2 raised to 2 minus 2, that is equal to 4 minus 2. You are already draw the diagram and show that 2 at the end of second generation, 2 will be there. Like that, for every generation you can calculate the amount of light DNA and you can choose the right answer. Okay.